Hello everyone, my name is Varadarajan, Assistant Professor, Department of Mechanical Engineering, SNS College of Technology. So in the last few video lecture series, we had discussed about the case study of limits and fit and tolerances. So now also we are going to deal with the same case study. So there are in the last few lecture series, we are discussing about the limits, fits and tolerance about the particular subject name of computer machine drawing. So we are already discussing about the introduction phase. The machine is a very important medium of assembly and an innumerable number of parts which has to be used for various assembly parts which has been used for bolts, nuts, screws, bearings, gears, chains, sprockets, couplings, etc. So we are going to deal with the particular subject, each and every individual parts, how it will be manufacturing in the different assembly sections, and also from the section of design and to development stage, we are seeing one by one. Okay. So here in the last video lecture series, we are seeing the definitions of the particular what are the different types of definitions. Basic size, what is the basic size, actual size, limits, maximum limit, minimum limit, tolerance. So, and actual deviation, upper deviation, lower deviations, zero line, tolerance zones. So what is the actual methods of tolerances? What are the different types of methods we are seeing? We are seeing that in that particular video individually with respect to the addition, symbolic representation and abbreviations. We are using the different limits of sizes also. So here in this video, we are going to deal with the machining variation for the dimension without tolerance indications. So for that, all dimensions inscribed on drawing of machined parts should be in the principle be associated with the tolerance data which are normally indicated on the dimensioning line after the nominal dimensions. So deviation for the linear dimensions. So here the dimensions of deviation which can be represented in the column wise, and also in the upper side of the actual row representation in the range of nominal dimensions value it will be representing. So in this table there are a few all the dimensions should be represented by using a millimeter value. So the next one is the without tolerant indications, deviation according to the radiations and the chamfers. So here the fine and medium coarse and extra coarse deviations, classes of deviation up to the including value of dimensions. So here the different dimension it will be represented over here. So up to from 0.5 to 120 and up to the including of 3 to 315. So with respect to that extra coarse value plus or minus 8 and plus or minus 4 and plus or minus 2. So the deviation for the angular dimension also it will be representing over here in the table. So the permissible variation of the length of the shorter side of the angle. So it also representing in the table. So up to 10 limit and up to 10 to 50 limit and 50 to 120 limit and over the 120. So here the same thing it will be represented over here in the column wise, coarse and extra coarse and fine and medium. So the machine, so actually the fits the machine is built by assembly. All its constituting parts during the assembling, sometimes a part may be required to be fitted into the another part. So that is actually the fit definition. So here the shaft and pole terminology based upon that in the mechanical engineering practices. So generally we are using the rod, circular cross section and circular hole are termed as the shaft and hole is the respectively. So here the mechanical engineering perspective, so the clearance also it is defined as the difference between the dimensions of the hole and the shaft assigned intentionally to obtain the particular type of a fit. So the classifications of the fit it will be established when one part is inserted into the another. The type of fit obtained between the two parts is governed by the dimensional deviations assigned for the basic size of the shaft and the hole. So here the types of fit we are representing over here, the clearance fit and interference fit and the transition fit. So we are going to see one by one in the types of fit. So the clearance fit, what is the mean by clearance fit? It is a fit established when a positive clearance exists between a hole and the shaft. So that is the clearance fit. So in this diagram you can see that. So the deviations of the tolerance value it will be representative over here. The diameter of the particular shaft it will be a 30.05 and 29.95. So this is the fit under tolerance limit value for the particular shaft. So the shaft dimensions also it will be represented in the different dimensioning, and also here the hole dimension also represent in the separate diagram. So here the hole and shaft it will be represented over here the separate diagram. So each and every diagram we can use two separate value. So here the clearance fit it will be defined as the fit established when the positive clearance exists between the hole and the shaft. So next one is the interference fit. It is defined as the fit established when the negative clearance exists between the sizes of the hole and the shaft. So here the diagram itself it will be clearly represented. So the transition fit it is also known as the positive clearance and the negative clearance. With the respective diagram, it will be clearly mentioned the respective dimensions also. So here the positive clearance it will be the diameter value 30 to 60 and the 30.55 to plus or minus 0.04. So here the transition fit will be happening by establishing the dimensions of the hole and shaft such as that there is a positive clearance or negative clearance when the shaft is finished into the hole. So this is the thing. Up to that, we can finish the case study of the fits and tolerance of the computer and machine drawing subject. So we will see in the some of the video with the different case study in the next week. Okay, thank you.